next video lecture of sets. Now here, before starting with practice set 1.2, we should know all these concepts. Fine. Now here, first we are going to see the types of set. There are 4 different types of set which we are going to learn. First one is what? Singleton set. A singleton set means what? A set in which only one element is there. That means one member or one object. That set is called as what? Singleton set. Fine. So here, singleton set. A set which has only one element is called as what? Singleton set. For example, A is equal to, in curly bracket 1 I have written. Now it can be 2 also. Instead of writing 1, it can be 2 also. That means a single element is there. Fine. Now, next is what? Empty set. Now empty set, or it is also called as a null set. And then what is empty set? Empty set is a set in which there is no element in that. So a set which does not have a single element is called as what? Empty set. So it is denoted by this blank curly bracket or simply by this symbol. This is called as phi. Ready? Now most of the students have a doubt regarding this null set. If they have given me P curly bracket, inside that I have written 0. Is this an empty set? No, it is not an empty set. Why? Because 0, a single one element is there and that element is nothing but 0. But if I remove this, yeah, I can say this is an empty set now. You getting? Now let us move on the next set, finite set. Next type of set is what? Finite set. A finite set means a set in which elements can be counted. This is called as what? Finite set. So this is a finite set. Yeah, because only one element is there. So I can count the element, isn't it? So finite set means a set in which we can count the elements. And then next is what? Infinite set. Infinite set, a set in which we cannot count the element. That means element is not countable. Fine. Now, for example, a set of all the natural numbers. That means what is start from 1, 2, 3, 4 and end till infinity, and we cannot count that, isn't it? So that is called as what? Infinite set. Fine. Now, after that we should know about equal set. Now equal set means what? Whenever we say that two sets are equal, that means they have exactly the same elements in that. See, if the two sets contains exactly the same elements, then the two sets are said to be what? Equal set. Now for timing, I will take an example. A, I have 1, 2, 3, 4, 5. And I am taking another set, B. Here it is 2, 4, 3, 1, 5. Now here, in set A, how many elements are there? 5 elements. In set B, again 5 elements are there. 1, 2, 3, 4, 5. Now I have to check that all the elements are present in this or not. 1 is present in this? Yeah. 2, yes. 3, yes. 4, yes. 5, yes. That means they have exactly the same elements. So I can say that set A is equal to set B. Fine. Now this was our required concept for practice set 1.2. So let us start with the practice set 1.2. Okay. Well students, see, let us start with the practice set 1.1. This is our first question. Now in first question they have asked me which of these sets are the equal sets. And we know that. What do you mean by equal set? If the sets had exactly the same elements, then we can say what? These sets are equal. Now they have given me 3 sets, but this is in set builder form or ruled method. Fine. Now what I will do? I will write them in a listing method. Fine. So let us start with the first. Now why I am doing so? Because they have asked me to justify the answer. So now A. What is A set? A is equal to set A is set of all x such that 3x minus 1 is equal to 2. What do you mean by this? Now first thing, this is the given condition. I have to solve this. So I am considering this 3x minus 1 is equal to 2. When I shift this minus 1 on this side, it will become plus 1. So 3x is equal to 2 plus 1, and that is nothing but equal to what? 3. So I got 3x is equal to 3. Therefore x is equal to 3 upon 3. So I got value of x as what? 1. So this is the only one condition which can satisfy this. So my set A is nothing but singleton set with an element 1. Fine. Now let us see about B. Now B, what they have given me, B is equal to set B is set of all x such that x is a natural number, but x is neither prime nor composite. Now which is that number which is neither prime nor composite? Only one number is there, and that is 1. So B has only one element, that is again 1. This 1 is neither composite nor a prime number. You getting? Now next, C. Set C. Now they have given me that set C is set of all x such that x is an element of natural number and that number should be less than 2. And we know that natural numbers start with what? 1. 1, 2, 3, 4, 5, 6, like that. And here they have specified a condition, it should be less than 2. That means only one element is remaining there. And what is that? That is again 1. So from this we can say that set A is equal to set B is equal to set C. And why? I need the reason. Because they have same element. That's it. Okay. Now let us see the second question. Well, student, let us see the second question. Fine. Now decide whether set A and B are equal or not, equal set or not. Now here they have given me sets in by rule method. So first I will write them in listing method. Now first A is equal. Now I need an even prime number, and we know that the number which is even as well as prime is nothing but 2. There is only one number, and what is that? That is 2. So A is what? Equal to 2. That means only one element is there. Now B, set B. Now for set B I have to just satisfy this condition. So set B is set of all x such that 7x minus 1 should be equal to 13. So I need to solve this. So I am solving this. 7x minus 1 is equal to 13. When I shift this minus 1 on that side, that will become 14. Isn't it? Minus 1 will become plus 13 plus 1 is nothing but 14. So I got x is equal to 2. So x is equal to 2 will satisfy this condition. That means there is only one number then. So here set B also contains only one number, and that is what? 2. Fine. So both the elements have same, both these sets have same element. So these two sets are equal. So I will write set A is equal to set B as they contain same elements. That is for 2. Fine. Now let us see the third question. Now what is the third question? Which of the following sets are empty sets? So they have given me 3 different sets, again in rule method, isn't it? Now I have to write them in what? Listing method. Now set A is set of all A such that A is a natural number smaller than 0. Now we know that natural numbers start from 1. Fine. And he needs a natural number which should be less than 0. So there is no any number which is less than 0 and is a natural number. You are getting? So there is no any natural number which is less than 0. So set A is what? Empty set. Or I can write it as A is equal to 5. Why this is so? Because there is no natural number which is less than 0. So I got A. So since A does not contain any elements, therefore therefore set A is an empty set. You getting? So this was about my first question. Now let us see second question. B. Now B is equal to what? Set B is set of all x such that x square should be equal to 0. So I should satisfy this condition. So I am considering that condition separately. X square is equal to 0. Now can anyone tell me which is that number whose square will become 0? There is only one number, that is what? 0. So x should be equal to what? 0. So this satisfies my condition. That means what? Set B contains an x whose value is 0. So I can write set B 0, isn't it? Now here the set B contains one element, and that is what? 0. Since it contains one element, it is not an empty set. Therefore set B is not an empty set. So set B is not an empty set now. You getting it? Now similarly third one. Now what is third question? C. Set C is set of all x such that 5x minus 2 should be equal to 0. And that x is an element of natural number. So first thing I will solve this condition. So what is that? 5x minus 2 equal to 0. Therefore 5x is equal to 2. Therefore x is equal to 2 by 5. And that is less than 1. Isn't it? Is equal to 0.4. Now this number means what? 0.4 is not an element of what? Natural number. Why? Because natural number start from 1 and this is less than 1, isn't it? So this is not an element of natural number. So x is equal to 0.5 satisfies this, but this does not satisfy this condition. So set C does not have any element, isn't it? Why? Because this is not an element of natural number. So I can say, therefore, set C is an empty set. Fine. I hope you are enjoying my lectures. Fine. Please don't forget to subscribe my channel and press the bell icon so that whenever I post my new videos, you will get an alert of that. Okay? Thank you. Yeah, well students, let us see the fourth question. Fourth and the last question of practice set 1.2. Now here, they have asked me to identify which of the sets are finite set and which are not a finite set. That means infinite set. And we know that finite set means what? The sets in which elements can be counted is called as infinite. And the set in which elements cannot be counted is called as what? Infinite set. Now first, they have given me set A is set of all x such that x should be less than 10. And x is a natural number. And we know that natural number starts with what? 1. So set A is equal to 1, 2, like this, 7, 8, 9. So you can count number of elements in this, isn't it? 1, 2, let it write it completely. 1, 2, 3, 4, 5, 6, 7, 8, 9. So you can count a number of elements. So here, set A is what? Finite set. Isn't it? Why? Because we can count the number of elements. Now let us see over here. Now set B is set of all y's such that y is less than 1 and y is an integer. Now y is less than 1 and y is an integer. So set B is equal to minus 3, minus 2, bracket close. That means what? All the numbers over here are less than 1, less than minus 1, isn't it? And it is countless because it starts from minus infinity. Or I can simply write it as what? B is equal to minus 2, minus 3, See, here I cannot count the number of elements in B. So set B is infinite set. Getting? Now, set C. What is set C? Set of students of class in 9th from your school. Now they have asked me a set of students of 9th standard from your school. Fine. So, yes, we can count all these students in 9th standard, isn't it? So, here I will write student can be counted. Therefore, set C is finite set. Set C is a finite set. Now here, fourth one. Set of peoples from your village. Well, yes, we can count. Peoples can be counted. No doubt, it will take 1 day, 2 day, 3 day, maximum 1 week, fine. Yes, but we can count that set, the people in our village, isn't it? So, peoples can be counted. Therefore, this set, which is this set? D, E, F, G. So, here, people can be counted. Therefore, this set, D, is finite set. Ready? Now next, E set. Set of apparatus in laboratory. So we have a science lab in our school, isn't it? Now in that laboratory, there are a lot of apparatus, conical flies, test tubes, and lot of things are there. We can count that. Yes, apparatus can be counted. Therefore, this set E, set E, is again finite set. The set is again a finite set. Now next, F set. Set of whole numbers. Now set of whole number. So, F is what? Whole number start from 0. 1, 2, dot, 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 dot. Isn't it? Now, in this set, we cannot count the number of elements because it is endless. So, this set is infinite. Fine. And the last question, G, set of rational numbers. Now, set of rational numbers cannot be counted. We cannot count the rational numbers because it starts from infinity and it will go on it is endless. So we cannot count rational numbers. And if we cannot count the rational numbers, therefore the set, and I have named that set as G, is set G is an infinite set. Right. So here we have completed our fourth and the last question. I hope you are enjoying my video lectures. Please don't forget to subscribe my channel and press a bell icon. And please like my video. Thank you.